I got the big printer down. I'm doing a bunch of work. I thought I'd show you some like old videos, some fails and whatnot, and a little bit of history about building my own big custom printer. Um, yeah, so I guess to start off with one mistake, one fail I don't recommend is using metal on metal. This is a direct bearing on. This is a steel bearing on a piece of aluminum, and you can see it leaves this dust, this metallic dust. So I recommend not doing that. Go with the traditional 3D printing Delrin wheel on a bearing. This is like a rollerblade bearing. Yeah, so I had a bunch of failures in regard to, I mean, this still works, it's just not ideal. I was trying to make this as simple as possible, but it's maybe one step too simple. I started off with this. This was the first X carriage, and it used these, and these are just static bearings, and these had way too much friction. I'll show you that. One thing that's interesting is this is the second X carriage, and this was all built just out of this was cut on a bandsaw. I cut this on a bandsaw. You used a drill, so you can make your own 3D printer with a pretty limited set of tools. This is just scrap aluminum cut up and just kind of screwed it all together, and it worked. And then this is the latest version. For the Y-axis, it uses Delrin bearings. So I tried all kinds of stuff. I'll show you. Things are leveled and squared. I accidentally bent this steel piece too far in the brake, but it might be a good thing because as I add weight, it'll bend forward. Yep, things are square, and I mean, pretty good. Now I'm going to add the Z-axis to this and see how it goes. This part of mounting the Z stage to this plate is a pain. So I have to go through these holes to the nuts on the back of the extrusion, and it's a real pain in the butt, so I felt compelled to document it. One thing I noticed is because of the load on the one side here, there's a lot more friction than there should be. So I thought about this before building, but now that I'm facing it, I'm thinking about moving this into the center to center the load. I think it would really reduce binding and friction. I had a feeling this might happen. The load here is so cantilevered over here that this is real hard to move. It's like putting all the friction on certain parts of the rail. So my X-axis is not going to really be it's not really going to work too well. I mean, the whole frame is moving when I move this, and it's not sliding. That's not good. Here's the first initial hopper design, first in paper. I put folds in it. This is going to attach here, and then these are the fold marks. I'm trying my first one here in aluminum sheet. One problem I'm having here is the 1x1 aluminum extrusion. It flexes too much. You can see here there's about I want to say that's about a 1/16 of an inch gap. Down along here. So that's too much. I don't like that. I got this 2x2 instead of the 1x1. This will be the very first movement of the machine. Here we go. I'm going to hit the limit switch below to stop it, of course. Whoa, oh, shit. I had some alignment issues where these rails were not parallel, so I added these wooden things at the end to keep them parallel. Actually, they're probably not even going to be exactly parallel because I just have one screw, but the combination of that and loosening up these screws a little bit actually really reduced the friction on the rails here, and I can move this freely now, which is pretty cool. I sprayed some WD-40 on top of the rails here, and the belt was slipping occasionally here, too much torque in some places, so that the WD-40 really reduced the friction, no more belt slippage. Now that I've added the Z and E axis here, there's too much friction, there's too much weight on these bearings, and the belt slips. So that's not good. I think I'm going to put it on bearings instead. I bought this Wheeler force measurement gauge here. It's actually for gun triggers, but it works really well for this application. I just take it here. I'm going to pull this about 20 inches over a couple seconds, and we can see how much force it requires. So I'm going to have some markings right here, and pull it along. Here we go. There's a little bit of extra force to overcome the static friction, but there we go. About like roughly 5 pounds to pull that 20 inches over, I don't know, like 4 or 5 seconds. Now for this test, as I pull this along, there's nothing connected to it. The motor's not connected, there's no extra weight of the head, the Z and the E axis. This is just this frame being pulled along the rails. Here we go, I attach the Z and E axis here. Let's see what we get. Somewhere around like 9 pounds. Yep. Well, I wanted to try something new, a new experiment, and use these sliders just to go along the rails and whatever for the 3D printer. And there's just too much friction for the motor. My ultimate vision was to 3D print these, and who knows, it still might be possible. I'd love to see somebody do that, like 3D print these sliders. That'd be awesome. But anyway, I couldn't get it to work. I might try it again in the future. We'll see. That'd be a cool project. But anyway, I put everything on these Delrin wheels now, and we'll see how much force is required. I have my gauge here. I'm going to pull it along just like before, and we'll see how much force is needed. I think it's going to be a lot less. Oh yeah, not even a pound. Holy moly. That's like a couple ounces. Just to quantify this, I'm going to move the frame now and roughly see how much it shakes. Try to estimate how much it shakes with each 50mm move. It's about a 1/16 of an inch. This is my first aluminum part cut with the Shapeoko, and as you can see, it didn't quite go all the way through. It's like really thin here, and I'll use a Dremel to cut it out. I had these tabs here, but I'll use a Dremel. It took about 6 hours to drill all these holes in the extrusion, to tap them, and that's a lot of time. 6 hours to do all that, and I'm thinking there could be a better way with like one solid piece of sheet metal bent. Made the bed adjustable height here with springs and screws here. These are M6. This should help the start of the print to get it fine-tuned so that the nozzle's within, you know, a millimeter or two of the bed height. Whoa. Starting to print, starting to print. I have to constantly do this. Some of these are too big. I have to filter them. I have to constantly push in the material. This is my first print. Let's see how it comes off. I'll get it. Yeah, it's not too bad. There we go. Thanks for watching, everybody. Take care. Happy printing.